want to look at now the Solow diagram in the basic Solow model, where we don't have any population or neighbor growth or any technological progress. So Solow diagram. So we want to look at the Solow diagram in this basic Solow model. Now there are three curves, as we can see over here, and we want to look at each one in detail to understand them. The first is the per worker production function. The y is equal to F where small y represents output per worker and small k represents capital per worker. Now the properties of this are, let's first discuss the properties of the per worker production function. We're talking about this function, the output per worker one. So the first property that we can see is upward sloping. Now why is it upward sloping? That's because we know an increase in K leads to an increase in output, right? So increase in capital per worker increases output per worker, right? So basically, output per worker is a positive function of capital per worker. So that's the first thing. Then, then the second is that it has diminishing slope, like you can see, or what we call concave. Diminishing slope, or what we call concave, where we can see that the slope starts deep, right? It starts deep. Slope starts steep, then gets flatter and flatter as the amount of capital per worker increases. We can see then gets flatter. So it has a diminishing slope, or what we call concave, then gets flatter and flatter as amount of K increases. Right, we can see initially the slope is something like this, and at this point we can see the slope is something like this, right? So we can see that it's upward sloping and it has diminishing slope. And mathematically, diminishing slope can be represented like this. Mathematically, we know upward sloping means that when the first derivative of y with respect to k is positive. A diminishing slope means the second derivative is less than 0. Which means that, so basically what we're saying is as k increases, y is increasing but at a decreasing rate. Before we look at that, let's just quickly mention what the economic assumption behind this is. Economic assumption. What is economic assumption behind the diminishing slope? Economic assumption driving the diminishing slope, right? What is the economic assumption? Driving diminishing slope. So it is economic assumption at play over here, because of which it has a diminishing slope, it's concave. So the assumption is production is characterized by decreasing returns to capital, right? Characterized by decreasing returns to capital, right? Which says that as capital increases with labor fixed, output will increase but at a decreasing rate. So when you're increasing K with labor fixed, then Y, then you get smaller and smaller increases in Y, right? That's why you have a diminishing slope. It gets flatter and flatter as the amount of capital increases. So the key over here is basically the per worker production function tells us that as K increases, as capital per worker increases, Y increases, hence it's upward sloping, but at a decreasing rate. That's why we have a diminishing slope, a decreasing rate or a diminishing rate. Right, so Y is going to increase as K increases, but you can see over here, if you were to increase, K, the increase in Y is this much. But if you were to increase by a similar amount, K over here, so the increase in Y is very minimal, right? So the per worker production function is upward sloping, which means this as capital per worker increases, output per worker is going to increase. Capital per worker is an input in output per worker, but this is going to happen at a diminishing rate because we're assuming decreasing returns to capital, which means the more capital you keep on adding with labor fixed, the increase in output is going to be smaller and smaller, and that's how we draw it concave. So now the next curve is going to be, so we're looking at three curves. The second curve is the investment per worker curve. So the investment per worker curve. Now, investment per worker curve is the SFK, where S is your savings rate. Let's look at properties of this. So if we discuss properties of this, so it has same shape as the per worker production function. So we can see the shape is the same because the per worker production function was Fk and this is SFK, right? You still have Fk. So same shape as 1, but lies below 1 as we can see, but lies below 1, i.e. the per worker production function, as the saving rate is between 0 to 1, right? So the saving rate, because it's between 0 to 1, so this is just a scaled down version of the per worker production function. So it's just a translated or scaled down version of 1 by s, right? So you have the same exact shape, you still have upward sloping, and you still have concave or diminishing slope, but now it's a translated down version by, so just translated down or scaled down version of 1 by s, because s is between 0 to 1, right? That's why. So this is the investment per worker curve. Now the last curve in this that we have is the depreciation per worker curve. Depreciation. Now depreciation per worker is also known as break-even investment per worker. So this is also known as break-even investment per worker. This is the amount of investment per worker needed to keep capital per worker constant in the face of depreciation, because only over here depreciation will reduce the amount of capital per worker. Later we'll see there are other things also incorporated in break-even investment once we add population growth and technological progress. So this is break-even investment per worker, and this is delta small k, right? Now, what are the properties of this? As we can see, it's an upward sloping straight line, right? It's upward sloping straight line, right? It's an upward sloping straight line. Now, why is that? That is because capital depreciates at a constant rate. The constant rate is what makes it a straight line, right? Capital depreciates at a constant rate, delta, right? So the constant rate is what makes it a straight line, right? Delta, where delta is between 0 to 1, right? And obviously delta is positive, so we know, okay, that's why it's upward sloping, right? So the delta being greater than 0 means that it's upward sloping. Right, so it's an upward sloping straight line because capital is depreciating at a constant rate. And obviously, the more capital per worker you have, the more depreciation per worker you're going to have. So that's why it says this. So now we've looked at the three curves. Now this last thing that you want to look at is in this diagram, how do we represent change in capital per worker? Now change, because we know our the main equation of the capital accumulation equation in per worker terms requires us to see what change in capital per worker is going to be. Change in capital per worker. Now we know change in capital per worker from the capital accumulation equation in the basic Solow model is the vertical difference the vertical difference between investment per worker and depreciation per worker, because we know we can derive the capital accumulation equation in per worker terms as delta k is equal to SFK minus delta k. So change in capital per worker is equal to investment per worker minus depreciation per worker. So graphically, it's the vertical difference between investment per worker and depreciation per worker, right? And depreciation per worker. So what we can do is let's just label this. Let's just label this as O. And let's just label this as I. And let's just label this as D, right? So over here, we can see that this is sorry, and then the opposite, this is D and this is I. This is I, right? So this is I. So now we can see over here that this is depreciation per worker graphically. OD, right? So depreciation per worker is OD in this case, right? And investment per worker is going to be OI in this case, and change in capital per worker isn't just going to be DI in this case, right? If we're looking at it like this, right? Because see, this is that, and this is like investment per worker, right? Investment per worker. So this is depreciation per worker, this is the investment per worker, and the vertical difference between them is essentially going to be delta k, right? Change in capital per worker. So this is like DI, right? Right. So this is this. Right, so like this we can also graphically over here visualize. So change in capital per worker is at any point it's just the vertical difference between the depreciation per worker curve and the investment per worker curve, and this we know through our capital accumulation equation in per worker term. So this is all about the Solow diagram.